All right, guys, the last couple of days we've been looking at the law of sines, which is side divided by the opposite angle is equal to side divided by opposite angle is equal to side divided by opposite angle. The law of sines is easier to use than the law of cosines, except for the ambiguous case. The law of sines is also easier to memorize than the law of cosines. The law of cosines is a little bit more involved. And we developed the law of sines using a right triangle. We're going to do the same thing with the law of cosines. Maybe tomorrow. I didn't have time to get that prepared for today. But the law of cosines has three different versions. All right? This is the first version of the law of cosines. A squared equals b squared plus c squared minus 2 times b times c times the cosine of a. It's one of them. The second version of the law of cosines is that one. B squared equals a squared plus c squared minus 2ac times the cosine of b. And then thirdly, we have this one. Let me give you guys a second to write that down, and then I want us to talk about some patterns that we see. All right, close. Now let me remind you of something before we discuss this, and I'm going to come right back to the screen in just a second. The cases that we're going to use the law of sines in are going to be whenever you have two angles, you always use law of sines, right? Angle, angle, side, angle is law of sines. And also the ambiguous case, which is side, side, angle, uses the law of sines. All right. The law of cosines is going to be the other two cases, which are what? Side, 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 and side, angle, side. So side, 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 and side, angle, side is the law of cosines. So the way that we I told you to remember this at the beginning was if you have two angles, right? If we know two angles, we're going to use the law of sines. If we know two or more sides, we're going to use the law of cosines, except for that one, the law of sines on the ambiguous case, the side, side, angle case. That's the one that's kind of varies from the rule. Two sides use law of cosines. Okay, so that's the exception to the rule, side, side, angle. All right, now let's go back and look at these two cases here for law of cosines as it relates to these two formulas, okay? If we go back and look at the formulas, if we have side, 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 then let's underline the pieces of information that we would know, right? If we have side, 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 that means we know A, B, and C. We know all of these things, and we're going to be finding this one unknown, right? If that's what we will be looking for if we know side, side, side. If you know all three sides, then we're going to have to find an angle first. Okay? What if we knew side, angle, side? So side, 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 we would know those three pieces. If we had side, angle, side, then obviously there's only one angle, which is this one. And side, angle, side has the two sides that are beside the angle instead of the side that's across from the angle. So we would also know A squared, C squared, A and C. So if we have side, angle, side, we're going to be finding this piece, side B. Okay, so you can kind of see, and the variables are arbitrary here. I'm going to show you that pattern in just a second. But you see how the side, angle, side, and side, side, side pieces of information are going to go. Now, here's how I want you to remember the law of cosines. You're always going to be finding one of the outside pieces. either the angle that's on the end or the side that's at the front. That's what we're always going to be looking for with the law of cosines. Okay, we can't find either of the sides, in any of these sides on the inside here, we'll never be finding those things. We'll always either be finding little c or big C, or little a or big A, little b or big B. All right? So kind of keep that in mind as we look at this. Now, what's a pattern that you see? How can you remember these formulas? Because you really only need to memorize one, and then you can kind of swap the sides around as you go. So how can you remember? What patterns do you see? Do what?
First half kind of resembles.
Yeah, it kind of resembles the Pythagorean theorem a little bit. You got the a squared, b squared, c squared in there. What else do you see?
First and second will be A and B switch, and the second and third B and C switch.
Okay, the first and the second one, B and C, or the first one, B and C are in the middle. The second one, A and C are in the middle. The third one, A and B are in the middle. What's always on the outside? What do you notice about the two outside variables? They're always the same, right? So the two outside variables always match, and the two inside variables are the other two, right? So when we're dealing with A's on the outside, little a and capital A, we have B and C on the inside. When we have C's on the outside, what two variables are on the inside? A and B. So you really have to memorize one of those and then remember the pattern, and we'll kind of look at that as we're going through. So the important things is remember the pattern, memorize one of these, and then you'll know how to swap things around. We're always going to be looking for one of the pieces on the outside of the law of cosines. So when you use the law of cosines, we're either going to be looking for little a, capital A, little b, capital B. It's always the pieces on the outside that we're going to use. And as we look at some examples, I will kind of tell you how to know which one of those we're looking at. So here's first example. Always draw a triangle. If the one's not given to you, draw it. This is going to be extremely important with the law of cosines, because I'm going to show you here in this case is where it's important. We mentioned this a few days ago. It's important to always find the smallest remaining piece first. The law of cosines is where that's important. Okay? We'll see that on example 2. What's the configuration of the three pieces of given information? Side, angle, side, right? SAS is law of cosines. Okay? The angle that you're given tells you which cosine to use. We're given angle B, so we're going to use the B version of the law of cosines. The B version of the law of cosines is B squared equals, remember the A and the C's go on the inside, so A squared plus C squared. And there's that minus 2 and another AC times the cosine of capital B. That's the B version of law of cosines. The B's are on the outside, the A and the C are on the inside. And this is A and this is C. And because we know capital B, this is the one we're going to be solving for here. Little b is what we're looking for. And this is actually the easier of the two versions of the law of cosines. When you're looking for a side, that's the easy one. Side angle side is easy. Side, side, side is a little bit more complicated, but just a little bit. Both of these cases are easier than side, side angle. So b squared equals, make your substitutions. We'll have 78 squared plus 84 squared minus 2 times 74 times, no, 78 rather, times 84 times the cosine of 102. Now the reason this one is easier is because we can take this whole expression on the right hand side and put it into your calculator all at once. You don't have to do it in pieces. See, Ma, can you Oh. All right, so you can put that whole piece on the right in your calculator at once. And when you do that, you're going to get something like b squared equals 15,000 or something, right? Leave it there. Don't do anything with it. B squared equals what? What do you get?
15,864.
0.47 what? Let's keep a
4748.
4748. So let's do 475. Now, the reason that I want to keep 2 or 3 decimal places here is because I want tenths place accuracy in my final answer, which means I have to keep extra decimal places in the problem. If I round too early and you round along the way, then you can be off. That's going to cost you points on the test. So I want your final answers to have tenths place accuracy. So through the problem, keep some. Now, the great thing about that is in your calculator, you can keep all of them. Just keep this in your calculator, and then b is going to be equal to the square root of that, right? So you can take that number that's still in your calculator, just hit the exponent key. And how do we take the square root using exponents? 1/2. So raise that to the 0.5 power. Use your exponent key to the 0.5 power, and you get b equals how much? 125.95. Is that right? Okay. 2 decimal places is enough here. 125.95 is our b value. So that's this. Now I'm going to stop right now and ask myself if that answer makes sense. Does that answer make sense? Should that angle be that much larger? Bye, Taylor. Should that side be that much larger? Yeah, sure. It's across from the biggest angle in the triangle, so it's going to be the biggest side, and it is.
When you plug it in, can you just instead of doing the second b square where you raised it like that, can you
start by putting it all under a square root symbol? You can, but you got to make sure that you use parentheses and don't close the parentheses until you get the whole expression in your square root. So what Charlie's saying, guys, is can you put it in square roots to begin with? Since you know you're solving for b, you could take this whole first expression. Well, I can't really get back to it. You can take this whole first expression right here and put it under a square root. If you do that, though, in your calculator, you've got to make sure you start with a parentheses here and end with a parentheses here to tell the calculator that you're taking the square root of the whole thing. Now, if you do it incorrectly, you might get a value that shows you made a mistake somewhere, so you can kind of be aware of that. But, yes, you can do it that way.
Are all the problems, are we going to be able to insert the whole thing like what we did here?
You're not. Okay? Side angle side allows you to do that. Side, you have to do some pieces. Okay? Side. You can learn to do it in one keystroke, but it's more complicated. Because if we're finding the angle, when we're finding the angle instead of the side, then it's we're going to be using inverse cosine at some point. So there's usually about 3 steps that you have to go through to get the inverse cosine value that we're going to use. That's why we're starting with side angle side today, and we'll do side on Thursday. Okay? All right, so once we find that side, here's what we're going to do. Now, because we know the angle and an opposite side, right now because we know these 2 pieces of information, we can switch to the law of sines. All right, we don't have to do the law of cosines again. We can switch to the law of sines, and that's going to give us this. Now, we're going to, at this point, this is where it becomes extremely important to find the smallest piece first. In this particular example, it doesn't make a big difference because we've already found the obtuse angle and there's not another obtuse angle. But obtuse angles give us trouble using sine. All right, we'll see that in the next example. But as a force of habit, we're going to find the smallest piece first, which means I'm going to find angle A next. Angle A is what I want to find next. So I'm going to use the law of sines. The sine of A divided by 78 is equal to the sine of 102 divided by 125.95. All right? And we're kind of pros at the law of sines. We've been doing it for a couple days. This 78 is going to move up here, right? And A is going to be equal to the inverse sine of 78 times the sine of 102 divided by 125.95, which is what? Is anybody there?
37.3.
37.3 degrees, approximately. So this is 37.3. And then to find that final piece, the easiest thing of all is just to use the triangle sum theorem that those three angles have to add up to 180. So I've got 139.3. 139.3 has to add up to 180, so that'll be, what, 40.7? Is that right? Somebody got that? Confirm it. So this is 40.7 degrees. Now, check to make sure that your triangle makes sense. These are the three pieces that we found. We found this piece, and this piece. Does that make sense with the given information? Is the smallest side across from the smallest angle? Yes. Is the largest side across from the largest angle? Because it is, the triangle makes sense. You should always check that. All right? And the next example is going to make it really clear why you should always check that. Y'all okay? Any questions before I move? All right, let's have a look at the next example. This is what this all kind of looks like in a screenshotted kind of way. This one. I need to put an angle there, 40 degrees. Now, y'all remember that you can never go by what you see in these diagrams. They may not be to scale. This looks like it's going to be an obtuse triangle. What kind of tells you it's probably obtuse? Do what? Angle B, but what's an even better indicator that it's obtuse? Side B, right? See how large side B is compared to the other side that we're given? It kind of tells us that angle B up there is probably going to be a pretty big angle compared to angle C. And C is probably going to be bigger than angle A. So I'm thinking this is going to be an obtuse triangle. And obtuse triangles are dangerous. Got to be careful with them. So we're going to be careful with all triangles. We're going to start out with law of cosines because we have side, angle, side. And because we're given angle A, that tells me I'm going to use the A version of the law of cosines, which is what? Y'all say it. A squared equals B squared plus C squared minus 2BC times cosine of A. I'm going to be finding little a, right? Yes, side angle side, you're always going to be looking for a side, and you'll be able to input the whole thing. So A squared equals, little b is 28, little c is 14, 2 times 28 times 14 times the cosine of 40. Because we know everything on the right-hand side, we can put this all into the calculator in one stroke and take the square root of it. And what is that? Well, let me give you all a second. It's going to give us a value for A. What do we get for A? 19.5? Yes? All right, 19.5. We got confirmation of 19.5. Okay? Now, I want y'all to put your pencils down because I'm going to show you a mistake. And I don't want you to ever do a mistake, but I want you to see a mistake. A mistake in this problem moving forward would be to find angle B next using law of sines. We can't find the angle B. If we find angle B next, B is the largest angle, right? At this point, we always need to find the smallest piece first. I want to show you what happens if you find the largest remaining piece using law of sines. If you do sine of B over 28 equals the sine of 40 over 19.5, we get B equals the inverse sine. Somebody punch this in for me. 28 times the sine of 40 divided by 19.5. I did the law of sines correctly. I've solved correctly. And we get a B value of what? 67.4 degrees. And I'm going to put that in, 67.4 degrees. And then what would the remaining angle be? 117.4 minus 72.6. Now let me ask you this question. Does that triangle make sense? It does not make sense. Okay? Because remember, the law of sines is going to assign equivalent positive values to acute angles and the second quadrant angle that belongs to that acute angle. All right, so really the angle that we want, and you could do it this way, you just got to be careful. The angle that we're looking for is 180 degrees minus 67.4. Okay? But just as a general rule, that's why we always have to find the smallest remaining piece first, because the law of sines does not work well with obtuse angles. If it's an obtuse angle, which this triangle is an obtuse triangle, you're going to mess up. But if you're labeling your triangle, you'll catch this error. If you're not labeling your triangle, then you won't catch the error. The triangle needs to make sense, and what we have here is nonsense. Okay? It doesn't work. So let's erase that and do it correctly. All right? We're not going to find the largest remaining piece first. We're going to find the smallest remaining piece. Now, if the smallest pieces that are remaining are both acute, it doesn't matter. Because it matters sometimes, you always want to get into a habit of finding the smallest remaining piece next, which in this triangle is angle C. So the sine of C, you can write this, divided by 14 equals sine of 40 divided by 19.5. Now the 14 is going to move up here, property of proportions, and C is going to be the inverse sine of 14 times the sine of 40 divided by 19.5, which makes C equal to 27.5. Nice round numbers here. So C is 27.5, and that makes sense, right? It's going to be smaller than 40 because it's the opposite side smaller. So 67.5 or 60, what's going to be the other angle? 112.5. Somebody subtract that from 180. What's 112.5 minus 180? Is it 67.5. That's the angle that we found when we did it incorrectly, right? So we really wanted the obtuse sister of 67.5, which is 112.5. the sine of 112.5 is equal to the sine of 67.5 because the reference angles are the same. Okay, so this kind of goes back to test 2 material and how it's relevant all the way through the class. Okay, so that triangle is solved. Does it make sense now? The largest angle is across from the largest side. The smallest angle is across from the smallest side. Okay, let's go, let's look at one more. I think you guys probably have this, but try this one. Let's try this one on your own, and then we'll practice. All right, you guys have a head start, so I'm going to start writing this up here. What'd you get for C?
Big number.
What'd you get?
329.95.
329.95. It doesn't seem right,
Yeah, I
does
think
it?
I'm putting it wrong.
Yeah, but it's good that you kind of saw that it worked. Is that what
I
you?
do the square root.
So that's what it's supposed to be before you square root it. So what is the square rooted version? 18.2. Okay, so is that accurate to 2 decimal places? We want to keep a couple of decimal places in our early values because we're going to use this value again. 18.16. Let's stick with 18.16. Remember, if we want our final answers, all our final answers to be in 2 single decimal place accuracy, we need to keep multiple decimal places in our early ones. If we wanted 2 decimal place accuracy, we might want to keep 4 decimal places as we work the problem and round at the end. All right, so 18.16 is here. What does that tell us about angle C? It's the largest angle, right? So this is one of those scenarios where the 2 remaining angles are, we know they're going to be acute, they're less than 80. So it wouldn't really matter which one we did first, but just to kind of keep good habits, the sine of A, we're going to find A first because it's the smallest remaining angle, is equal to the sine of 80 over 18.16. Then here's where we're using that value, right? We're using 18.16 instead of 18.2. It's going to give us more accuracy in our final answer. That means A is equal to, 10 moves up, the inverse sine of 10 times the sine of 80 over 18.16. A is approximately how much? 32.8. All right. And that means that the remaining angle has to be, what, 112, 67.2? Do we have a triangle here that makes sense? Smallest side is across from the smallest angle, and the largest side is across from the largest angle. Okay, is everybody good? Now, on your homework tonight, there's going to be 2 sections. The first section of your homework is just law of cosines, and it's just side angle side version of law of cosines like we did in class today. Thursday, we'll add law of cosines side. Okay, the second section of your homework has law of cosines and law of sines, and doesn't specify which method you have to use, so you're going to have to look at the configuration of the problems and then decide. So it's the first kind of glimpse of the next test where you're going to have to decide which method is the appropriate method to use for the problem. And all of our homeworks moving forward will have a little bit of both on it. All right, so that's what we're going to look at.